Okay guys, so I'm going to go through and I'm going to explain some of the basic steps that are required in Chapter 13. These are some skills that you should have gotten during the chapter, but it's nice to always be able to refresh so that you can do the extra assignment that you need to do. Okay, so first of all, I'm just going to show you a really quick and simple re-explanation of cross multiplication. So here, what I have is 8 over 2 plus x, doesn't seem like plus, but that's a plus, equals 2. Now, in order to solve this problem, since your x is in the denominator, what you need to do is cross multiply. So the 2 is actually over 1. Okay, and what you're going to do is you're going to multiply 8 times the 1, and then 2 times that 2, and 2 times that 2. So what you end up getting is, I'm going to first do it this way. So 2 times 2 is 4, so 4 plus 2x. Okay, so that's what I got there, and that equals 8. Now, what a lot of people like to do, if they have this kind of in reverse, so they say, oh, okay, 2 plus x over 8 equals 2. What they like to do is multiply both sides by 8 and then solve for x, which you can do if x is in the numerator. But since x is in the denominator here, you need to cross multiply. I always cross multiply, never don't cross multiply. So here's what you have. Now you need to solve. So isolate x first, so subtract 4 from both sides. Okay, so what you end up with is 2x equals 4. Okay, that's equals. Now, in order to solve for x, I need to divide both sides by 2, and what you get for x is 2. And that's it. Okay? So what we're going to be doing in all of these problems, we're going to be looking at a formula, and then it's just a little bit of math required. All right, so it really shouldn't be that bad. The reason why I went over cross multiplication was that for mass percent and volume percent, which I don't actually show here because they're the exact same thing, you might be doing cross multiplication. So for mass percent, what I always tell you guys to do before you even think, write out your formula for mass percent. So you know that percent equals the mass of your, and I'm going to abbreviate because writing on this is awkward, mass of your solute over the mass of your solution. Remember, solution is your solute plus your solvent. Okay? And then you need to multiply this by 100. Okay? And that's it. So all you have to do when you're looking at a problem is figure out what I tell you, plug it into the formula, and then go from there. So for example, here, I tell you have 12 grams of solute. So that's going to go up there. That's the mass of the solute. And I tell you the percent, okay, which is going to go right here. Remember, since it's a percent and since I multiply by 100 here, before I plug this in the problem, don't put 2.4 right here. You need to move the decimal place over 2 places. So if you do that, 1, 2, what you end up getting is 0.024. So 0.024 equals, now this is the mass of my solute, so it's going to go up above 12.0. Remember, the mass of your solution is the mass of your solute plus your solvent. So I know my solute, so mass of my solute, plus the mass of my solvent, which I don't know, so I'm going to make that x. Okay. So I'm not going to do this whole thing for you. But what you need to realize is this problem, this setup, is identical to this one. All you're going to do is cross multiply. So what you're going to do is you're going to have 12.0 times 1 equals this times the 12.0 plus 2.024 times the x. Okay? And then you'll solve for x. So look back here and remember what you did. You did, oh, sorry, it's up here. You did 2 times 2, which is 4, plus 2 times x, which is x, 2x, which equals 8 times 1, which is 8. Do the exact same thing here. Don't get freaked out about the numbers. The only other thing that you need to remember is the fact that you don't want to round it till the very end. Okay? And then once you're at the very end and you're thinking about rounding, this has 2 sig figs and that has 3, so your final answer needs 2. Okay? I'm going to move on and I'm going to talk about molarity. Now, for molarity, before I even start, because I see in the problem it says what's the molarity, so I automatically know it's a molarity question. I'm going to write out the formula. So your molarity equals your moles of your solute over liters of your solution. Okay. So The reason why this is a pain in the butt is if you notice, for your solute, which is salt, I give you it in grams. So based on this formula, without even thinking, guys, you guys should automatically be thinking, crap, I have to change it to moles, which is easy enough to do. I'll set it up for you. I won't do it, but I'll set it up. So 2.0 grams, I need to convert this to moles. So before you freak out and are like, I don't know the conversion or anything like that, just write it out. So I put grams on bottom, because these will then cancel, and put moles up top. As soon as you see grams and moles, you should be thinking molar mass. So the molar mass of NaCl needs to go with grams, because the units for molar mass are grams per mole, and then a 1 goes with the moles. So you'll get your answer. It's whatever moles. Okay. And then you need to divide that by the liters of solution. Now, if you notice here, I give this to you in milliliters, which is the pain in the butt, but you still can do it, I promise. So what you're going to do, you need to convert it to liters. You're in mils right now. If you can do it in your head, awesome. If not, write it out like what I'm doing here. I'm going to put mils on bottom, liters up top. Remember, liters are bigger than mils, so in 1 liter, there are 1,000 milliliters. So you need to take 310 divided by 1,000, and what you end up getting is 0.310 liters. Okay? This is your molarity, whatever you get for your answer. At this point, you can round. Notice it says 2 sig figs, it says 2, and your units for molarity are molar. Now, I can mess with this problem in any way, shape, or form that I want. I could give you the molarity and, I don't know, mils of the solution and ask you to solve for grams. Okay? It's a pain, I know. What you first have to do, plug everything in. You can put the molarity in, make sure this is in liters, and then you can solve. So let's say the molarity, I don't know, is 2. Okay. The milliliters of solution are, let's say it's 310 again, so I'll put 0.310 here. And I'm solving for moles. If I ask you to solve for grams, what you have to do is first solve for x. Okay. That'll be in moles. And then you'll say however many moles, x moles, it could be, it's actually going to be 0.620, but it's whatever, that many moles, now convert it into grams. So yeah, it's a bunch of steps. I'm going to put moles on bottom, grams up top, put the molar mass of the solute there, and you're done. That's it. You're now in grams. So instead of freaking out and not writing anything or, putting stuff that we've never used before, make sure that you're thinking, first write the formula. All right? For freezing point depression and boiling point elevation, these are really, really easy because I give you a formula. So for the freezing point, this is the change in temperature, okay, of the freezing point. And it's your molality, little m, molality, times your Kf. I give you your Kf at all times. Molality, remember, it is moles of your solute divided by kilograms of your solvent. So it's a little bit different than molarity, but still you can totally solve for it. Now, let's say, for example, I give you the molality, you have the Kf, and you solve for your delta Tf, and you get that it is 2. Okay? I added salt to water, and I found that the change in freezing point was 2. Now, if I'm asking you for the new freezing point, I don't want 2 degrees Celsius. That's not the answer I want. The normal freezing point of water is 0. So if the delta Tf is 2, what that means, it's freezing point depression. So it's decreased by this much. So your new freezing point is going to be negative 2 degrees Celsius. Okay. Same thing for Same thing for boiling point. Okay, except the exact opposite. It's boiling point elevation. So I get my delta Tf. Delta Tb, we're dealing with boiling now, equals your molality times your Kb. So let's say I solve it. You found your molality, you calculated your delta Tb, and let's say it was 4 degrees. Since this is boiling point elevation, that means that my answer is going to be this much above the normal boiling point. The normal boiling point of water is 100, so my new boiling point is going to be 104 because I added it. Okay? So that's it, okay? The only other problem that I gave you, and I'm going to scroll down and try and get you a new page. The only other type of problem that I gave you was a a dilution problem. Okay, and so let's look really quickly at a dilution problem. All right, so you've got a concentrated solution, and the concentrated solution has a molarity of 12.0 molar. Okay, and I want to create a 5.0 molar solution, and I want, because I have a bunch of students, I want 2 liters of it. Okay. So the hardest one, the problem that a lot of people had issues with was exactly this. How do I make this if what I'm given is a 12 molar solution? Remember, the formula you're using still is M1V1. Whenever you're doing dilutions, M1V1 equals M2V2. Okay. Now, I want to figure out what concentration of this I need. So I'm going to say, okay, sorry, what volume of that I need. So I'm going to say, okay, I've got this concentration. I don't know what volume of it I want, but I know in the end I want a 5.0 molar solution, and I want it to have a volume of 2 liters. Now, notice in molarity questions, I told you had to be in liters. For these problems, since you've got 1V here and 1V here, you could be in milliliters, and then that would be in milliliters. Just make sure that they match up. So if this is in mils, this is going to be in mils. If this is in liters, this is going to be in liters. Okay. So what you're going to do is you'll solve for V. So V1 equals, so 5 times 2 is 10, 10 divided by 12. Okay. So here, this is the volume, right? I would put this in a decimal if I were using a calculator, but I need this amount, so 10 twelfths, this would be a decimal, liters of my 12.0 molar solution. Okay. This is the first step. This is what I need. But then I want 2 liters. Okay. I want 2 liters of my final solution. So the really cool thing about this, once I add this much of my stock solution, of my concentrated solution, the rest I just need to add as water. Okay, the rest needs to be water. So this ends up being, if you do your decimal correctly, I need to add this much of water. And the way that I got this answer was I just did 2 minus 10 twelfths. The rest is water. So what that does, it's super cool. All you're doing, you're adding this much of your concentrated solution. If you add this much water, you'll end up with this volume and you will have this concentration. So it works out super nicely. Okay. Now, that's the hard dilution problem. Let me give you a really easy one. All right. Let's say I have a 5 molar solution. I have 2 liters of it. Let's say I want a 2.5 molar solution, okay? What volume of that will I need to make? Again, same formula. M1V1 equals M2V2. The hardest part of these problems, guys, figuring out what goes with what. So I've got a 5 molar solution, and I have 2 liters of that. I want a 2.5 molar solution. What volume will that have to become? So 5 times 2, divide both sides by 2.5, and you have your answer, and your answer is in liters. That's it. That's all there is to it. So the hardest part, guys, figuring out, here's your formula, figuring out where everything goes. If I ask you to explain how to make the solution, I'm probably doing a dilution problem, which is the problem I just did before, where you find out how much of your stock solution you need, and then you add the rest as water. Okay? And that's it.